Okay, in this video we are doing Calc Problem Set 61. The problems and a playlist are in the description below. Let's do this. Determine where f of x is concave down given f prime is the quantity 3x plus 5 to the fourth times the quantity 2x minus 9 to the fifth. It's good that this is already f prime, because if we had to find f double prime from f and f looked like this, that would be not great. But this is already f prime, so we're going to find f double prime. It's going to be a product rule with some chain rule. I'm not going to make you watch the whole thing. So we got the quantity, so it's like first, derivative of the second, you have a 2 from the chain rule and a 5 from the power rule, so that's where 10 comes from. Second, derivative of first, 12 is coming from 4 from the power rule, 3 from the chain rule, so that's where those come from. You look at this, you can definitely take out a 2 from everything. You can take out a 3x plus 5 cubed. You can take a 2x minus 9 to the fourth. So I'm going to do that. I'm going to correctly leave. So when I take out 2 from the first product, there's still a 5 left over, and it's going to be 5 times 3x plus 5. So that's where 15x plus 25 comes from. When you take 2 out of the second product, there's a 6 left over, and that 6 goes with 2x minus 9. So that's where 12x minus 54 comes from. You have to simplify this to be able to really work with it. So I've done that. Now, what are the zeros of this? Negative 5/3, 9/2, and 29 over 27. Make sure you put them in the right order on your sign chart, though. If they're in the wrong order, you're going to draw the wrong inferences. And now we have to test or whatever. I'm going to take negative 1 billion and plug it in. That gives me 2 times a negative number times a positive number times a negative number. So there's 2 negatives. That makes a positive. So pluses. All right, negative 5/3 comes from a factor with a multiplicity of 3 that's odd. So there'll be a sign change. Negative 29 over 27 comes from another odd-powered factor, so there's going to be a sign change. And then 9/2 comes from 2x minus 9 to the fourth. That's even-powered, so there won't be a sign change, so we'll get pluses. That's how I do it. You can also just pick numbers and test them. It's kind of annoying to test numbers, though, when you can do it this way. It's totally up to you. All right, concave down would mean the second derivative is negative, so I'm going to write up my answer. F of x is concave down from negative 5/3 to 29 over 27 because f double prime is less than 0 there. Good answer. Let's move on to the next question. All right, evaluate the integral from negative 1 to 4 of the absolute value of x minus 1 dx. We've seen this a number of times, and we hopefully know at this point, best way to do this is to just graph the absolute value of x minus 1 and probably just add up 2 triangles. So I'm going to do that. So the relevant points that we need are at negative 1, which is one of the boundaries, at 1, which is the vertex, and then at 4, which is the other boundary. Just plug them in. So if you plug in negative 1, you get 2. When you plug in 1, you get 0. When you plug in 4, you get 3. And now we're just finding those areas. So the first triangle is half of a 2 by 2 square, so 2. The second triangle is half of a 3 by 3 square, so 4.5. And then we add them together to get 6.5. That is by far the best and easiest way to do that problem, and I hope everyone fully embraces that, because when we do review work, there's at least one problem in some of the review tests like this, and every year somebody's like, how am I supposed to do this? I'm always like, I said it 1,000 times. How do you not know by now? But hopefully that doesn't happen this year, because hopefully everyone's doing these problem sets. All right, next question. Use the graphs of f and g above to evaluate the limit as x approaches 4, g of f of x. So this is a complicated looking limit because it's like a composition. But what I want you to do is never panic on these and just start thinking, how could I do this using one-sided limits, right? So the first thing I'm going to do is I'm going to look at the limit as x approaches 4 from the left of just f of x. Let's figure out what f of x is approaching, because let's say f of x is approaching 2. So then really we're trying to figure out what happens to g of x as the thing you're plugging into it approaches 2, right? So that's the idea. So I need x approaches 4 from the left of f of x. You can see that f of x is approaching 3 from below 3, so that would be like 3 from the left. Now, what I want to do is I want to figure out what happens to g of x as the thing that I'm plugging into it approaches 3 from the left. So it becomes now this problem. The limit as x approaches 3 from the left of g of x. So I go to g of x and approach 3 from the left, and I think that's approaching 4. Okay, now we just do it again, but from the right. So limit as x approaches 4 from the right of f of x. So that's approaching 1, but from numbers bigger than 1. So that'd be like from the right, because numbers bigger than 1 are to the right of 1 on a number line. You're always thinking on a number line when you're thinking left to right. Although it's the case that like from below and from the left are basically the same, and from above and from the right are basically the same. So now we need to see what happens to g as the thing that you're subbing into it approaches 1 from the right. So that becomes this problem. And then we just look at the graph of g of x and we try to approach 1 from the right. So like this, that's approaching 4. So because both of these are the same, we can say overall the limit as x approaches 4 of g of f of x is 4. That's how you're going to handle those basically every time. They're not something you need to like freak out about, but like I understand that's a complicated looking limit, and I think most people, if they just had to guess, they would be like the limit doesn't exist, and they would just like move on. But it's not the case, because when you use one-sided limits, you see that it ultimately does approach the same thing from the left and the right. All right, next. Given that y equals f of x, dy dx equals 5x squared y, and f of 2 equals negative 3, write the equation of the line tangent to y equals f of x at x equals 2. All right, this is a very straightforward problem at this point in our lives. But there was a time where this wasn't straightforward, especially because dy dx, the derivative, is implicit. It has x's and y's, and when you're first learning, that like really freaks people out. All right, so we're going to evaluate the derivative at the point 2, negative 3 to find the slope. So it's going to be 2 squared times negative 3. So that's 20 times negative 3, negative 60. And then we know the ordered pair is 2 comma negative 3, so we can just point slope this and be done. So the tangent line looks like y plus 3 equals negative 60, the quantity x minus 2. That's the end of the problem set, so I hope this was helpful, and good luck.